right, so let's get going here so we can actually do all that and get us out. The endocrine system deals with one's hormones. Hormones are chemicals that flow through the bloodstream. They attach themselves to body cells via receptors on the surface, and then they influence the target's function. Hormones are secreted by glands. Glands make hormones, but they also make other substances that don't go into the bloodstream, that they exit the body. What do we call those? Exocrine glands. Okay. So we want to, initially when we look at glands, we want to differentiate between endocrine glands, which endo means inside. They secrete their stuff into the bloodstream, that's inside the body. And exocrine glands, like your sweat stuff, they exit the body, that's why they're exocrine glands. So that's what you need to know with that. The other thing that's very important, I think, as a concept, generally also for this system and the nervous system, actually a lot of what's going on in the body is this concept of receptors, specific receptors. So you have in your endocrine system, you have hormones, which are chemicals that flow through the body, through the bloodstream and go to cells. And then on the cells, you have receptors. And the receptors recognize the shape of the hormone. It's a shape question. It's very, very specific. And when there is a receptor to a specific hormone, then the cell gets activated in doing something. All right, so it's the hormone that's the messenger, and the receptor that actually does the reaction. So don't kill the messenger. It's kind of the message on that. All right, so then we go. The nervous system is a fast-acting system that is short-lived. Nerve cells send an electrical impulse quickly along a wire. They release a chemical at the end point. It's a chemical too, it's like a hormone. It's just at that point it's called a neurotransmitter. But it's the same concept because you also have a target cell with a receptor on it, and that could be a muscle that contracts when the nerve impulse fires. But it's still a chemical, that it's acetylcholine, that makes that reaction happen. And then hormones on the other hand trickle through the bloodstream. They don't go over a nerve. The electricity is fast. The nerve is like a river. The bloodstream is like a river. It's slow trickling down. So that's the hormones. They go through the bloodstream until they find a matching receptor on a cell. And then you have a reaction happening. So the hormones work slower, the nerves work faster, but on the other hand, the great thing is the hormones work longer and the nerves work shorter. And so these are great, hormones are great things for ongoing processes that take time, such as body growth, for example, reproduction, metabolism, that stuff. So the nervous system is said to be quick and short-acting, and the endocrine system is said to be slow and long-acting. Is that true or false? That's true. Yes, Karen?
No, I think you answered it. Thank
Okay. And so that's what I want to compare and contrast, basically. I like this, gives us some of these data points. Well, that's pretty much what I needed to know on this topic. Ooh, and then back to hormones now. Good. Come on, baby. So that's again the receptor changes the cell's activity. The hormone is only a messenger. They come in two different main classes. One is water-loving. The other one is water-fearing. So one is lipophilic or fat-loving or water-fearing. Lipophilic means fat-loving. Hydrophobic is the same thing, it means water-fearing. So those are AKAs, just depending on how you describe it. They can easily penetrate, the hormones that are fat hormones based, they can easily penetrate anything that's fatty. The phospholipid bilayer of the cell membrane, that's fat, a fat film, an oily film. So they can penetrate that and then go through the cell membrane, through that process, and attach themselves to the receptor on the inside of the cell. The other one, the water-loving hormones, however, cannot pass through the cell membrane. Where do those receptors attached. Where are those receptors located? On the surface. So they cannot. The fat, these are fat. Lipophilic is the steroid hormones. So if you see steroid, you think fat. You think cholesterol, actually. You even go that far. And so they can just go nice in. And it's often, very often the receptor is on the not close to the nucleus because somehow we're going to do protein synthesis or something that's a change. And then a peptide hormone, which is the hydrophilic, the affinity to water hormone. So they also call that a peptide hormone. And that attaches to the receptor on the outside. And the receptor itself changes something on the inside of the cell, and then that creates the action. So the important thing here is, so when you go to a higher end class, bio 28B or 4, you're going to talk about second messenger. So the second messenger refers to the fact that the hormone needs to be attached to a receptor, and then that changes to the inside, and then the messenger is on the inside. So that's the second one. So you associate second messenger to hydrophilic. Fundamentals, that's good. Ooh, look at that now. We're getting right into it. Basically, a lot of this chapter is, what's the gland, what is it going to do? Well, let's not go there. Hormones are secreted by many body cells. For example, muscle that is not used releases myostatins. Did you know that? Because as soon as I knew that, I put it in a question. Because I think it's very important. They're not used to release myostatins, hormones that influence many body functions negatively, increasing likelihood of diabetes, high blood pressure, and so forth. So couch potatoism ain't going to work out in the long run. A muscle that contracts, however, releases myokines, which are hormones that influence body functions positively, decreasing blood pressure, etc. Who knew that muscle tissue acts as an endocrine gland? For a long time, we didn't know that. That stuff comes out like a little bit at a time as we go along. We didn't have that in class when I went to Cairo school. Well, that was a long time ago, I guess. So in here, however, we don't talk much about these gland, every sort of body organ that has a main function and then a glandular function, like the heart has some glandular function, the lungs have some glandular function, so they all secrete stuff that has influences. But we're going to focus on the main glands that only deals with hormone release. And so most of those hormone secretions, so that's the thyroid gland, the adrenal gland, all that kind of stuff. Most of those secretions are controlled by a negative feedback loop, which is designed to have to keep many chemicals in the blood at a certain range. So again, the negative feedback loop is you got a range within where you want to have the pH be, when you want to have the blood glucose level be, for example. If it goes too high, you got to do something to bring it down. That's the negative part of the feedback loop. If it's too low, you got to bring it back up. So very often in a hormone, like in a blood glucose hormone, we're going to have one that brings the blood glucose level down and puts the sugar into the cells and all that. Then we got one that if the blood glucose level is too low, we're going to bring it back up. So we got another hormone that's going to do the opposite, it brings it back up. So often we have these two hormones that two different opposing functions. Not always, like in growth, you just have a growth hormone present or not. That's more of an ongoing slow process. But chemoreceptors in the body are very important because they measure chemical levels that then influence the gland secretions in the body. Many chemoreceptors are located in the brain, in a part of the brain that then influences the endocrine system. So the brain part reads what's going on and then it decides what to do with the endocrine system, and it talks to the different glands through a process and then releases those, then release the appropriate hormones when necessary. So where are those chemoreceptors located? The hypothalamus. The hypothalamus comes back over and over as we talk about the brain. And also hypothalamus is a very important organ for the mind-body connection. It's the when psychosomatic diseases, for example, when we're always stressed out, it's the hypothalamus that talks to the rest of the body and adapts the rest of the body to the environment, a lot of it. So that's a good one to know. And then the hypothalamus influences the next gland in the brain, and that's the one that sits right by the cella turcica. What was that one? Do you remember? The pituitary gland. Is that the next question? Oh, the pituitary gland is a small gland, sits in the center of the skull, cella turcica. It has two parts to it, which together release 8 hormones. So that's a big. We often think of the pituitary gland being the master gland in the body. It's tiny, you know, the cella turcica is tiny, so that sits in there. But the king of the pituitary gland, or the queen, is the hypothalamus. So who influences the pituitary gland is the hypothalamus. And so the hypothalamus, the pituitary gland has 2 parts to it. One is a posterior lobe, and that is actually kind of like an extension of the hypothalamus. So the posterior part is a direct neural connects the hypothalamus, which controls the hypophysis, and you want to associate that name hypophysis with pituitary gland. If it comes back at some point, it's not like first level of knowledge, but if you read hypophysis, you got to click the pituitary gland. One of the 2 hormones released from that lobe is the antidiuretic hormone, or I call it the anti-P hormone, because that controls how much water gets excreted in the urine. And that is influenced by what? Coffee and alcohol. So if you have coffee and alcohol, you've got to go pee all the time, this hormone is not there. It's inhibited. So it's kind of cool, because that's one of the places you can actually understand what the hormone does. It's kind of like the jitters when you have the adrenaline go up because somebody scared you or something. Or me. I know, Halloween. Did you get scared on Halloween? We went walking and there was like this place that looked like American Horror Story kind of yard. And I talked to someone, was like, that looks like alive or so. Then somebody jumped up and I was so. She's like, it's too good she didn't have a video of me. I look like a little girl. So anyway, that's the antidiuretic hormone. What's the other hormone that's released by the posterior pituitary? Oxytocin. Good, let's look at that. Ooh, look at all these. This is a good picture, actually. It's a little overwhelming, but see here, you got the hypothalamus. This is the hypothalamus, I guess. The hypothalamus has nerve connection straight to that pituitary gland in the back. So we also call that the neurohypophysis. See, that's the hypophysis, is that old name again. Neurohypophysis, because it's connected straight to the brain. And we got there releasing ADH and oxytocin. Where are the ADH and oxytocin? See, there we go. So ADH, diuretic, you associate with peeing. And so, that hormone through that process raises blood pressure. So you think of less peeing, less water going out, more volume in the blood, higher blood pressure. So that's what we regulate with that. And then oxytocin promotes uterine contraction in labor and the milk ejection during breastfeeding. And then it also plays a role in sexual arousal and orgasm. So that's a cuddle hormone, the affectionate hormone. So that's what's there. That's the second one. So that's very important. And then the next question talks about all the other ones, which are released. So let's go for those. Yeah. Let's just go through them, Too many of them. So we got a few of them, We got the growth hormone. What would that do? Works on the body's growing parts. So it's like how big and how tall and how muscular and all that kind of stuff. So it works mostly on the bone and the muscle. So that's released straight from the anterior pituitary, or also known as the adenohypophysis. Adeno is glandular. If you read the word adeno, you think gland. So that's one that goes straight to the bloodstream, straight to the targets, and does its work. That's not one we got one and the other. We got a grow or we don't got a grow. We don't have a shrinking hormone, we just have a growing hormone.
Has nothing to do with metabolism.
No, that's the thyroid. And then we got prolactin, and that stimulates the cell division and secretion of milk in the mammillary gland and enhances testosterone in the male. So that's one of those. So you think prolactin and oxytocin, you kind of think together a little bit. And then we got FSH and LH, follicle stimulating hormone and luteinizing hormone. The FSH stimulates the maturation of the follicle in the ovary and promotes sperm production. So that's the reproductive stuff. And the LH works on the ovulation in the male and the woman, and the testosterone in the men, enhancing. So that happens with the cycle, menstrual cycle works with that. And I like this, it's just so FYI information. There's like differences between the FAs, LH, estrogen, progesterone. Some of that is, too much for in here. So just that's why, remember, for the knowledge piece, for the examination, for this part, the review. Go with the test tube. Do not even go further with making flashcards. I mean, it's always nice to learn more, but the chance of getting overwhelmed is just too great, I think. And so if it's on the test, it's not on the review, it's your point. Okay? So don't be afraid, oh, maybe there's something else or something else. You point out to me, we'll take care of it. If you show me a study, I take care of you to make sure you have a good grade. If not, well, by now you're not here anymore. Then we got the Adrenocorticotropic Hormone. Holy cow, that's an interesting name. Adreno refers to adrenal gland. That sits on top of the kidneys. The kidneys are the renals, the renal system. And a corticotropic hormone, what is cortical? Cortical means a shell, and trophic, I forgot what trophic means. But the adrenocorticotropic hormone from the adenohypophysis goes now not directly to the gland, to the body cells. It now goes to the gland, the adrenal gland, and in the adrenal gland, it works on releasing the adrenal hormones. All right? So it works on releasing cortisol specifically. And then cortisol has a function on the body. So this is getting a little complicated. So this is a two-step process right here. Right? And then cortisol does all this stuff to the body. It makes sure your attention span is good. It makes sure your blood sugar is good. So it's a stress hormone. So you can run away from the lion. But it also suppresses the immune system, so we don't take resources away from that. If it's a matter between being eaten up or running fast enough, you don't care about your immune system for that hot second. Etc. It also decreases sensitivity to pain. That's why we give cortisone. Cortisone is the artificial synthetic of cortisol. And so that's important to understand when we get to the adrenal gland and look at the stresses. Because long-term cortisone use, when I get a 30-year-old in, it's like, oh, my knee hurts, doc. The doc gave me want me to give me a cortisone shot, or I want a cortisone shot or something. It's like, no, hell no, you wait till you're 70 for that. Don't just and then what are you going to do? Oh, my knee not hurt anymore, it's fixed now, and then 2 months later you're going to be crippled again because the cortisone does not fix it. It just decreases the pain and the inflammation and gives you a window to fix it, so to speak, but no pain out of the brain. And so, unfortunately, as humans, we don't want the pain, but we need the pain to be driven to doing the right thing sometimes. So anyway, that's the cortisone thing. I did have a patient, they say you give cortisone like a few times a year and that's it. Not too many, that's the challenge because of all these effects. I had a guy and he had I think he had 28 injections in the back in one place. And when I worked on that thing, it felt like the rib was glass. In terms of, fragile, if I press too hard, it would break. You can feel the body tissue if you do this for 30 years. And it was like, oh, that's not good. And so I saw that demineralization, they don't even put that in here. It takes away, it creates a little bit of localized osteoporosis if it's too much in it. But anyway, it's a really good hormone, we need it. But we just, and it's a really good medication, we also need it. We just need to be careful how we implement it. Okay, so let's go back one more step with that I wanted to bring up here. Where are you? So now we have this step for the pituitary gland brings the hormone to the adrenals, and then the adrenals secrete this cortisol. Now we go even one step higher, we go to the hypothalamus. So the hypothalamus is that master gland. It secretes a couple of hormones itself in the neurohypophysis, but for the for the one in adenohypophysis in the front, it actually has a little nervous, no, wait a minute, where is that? That's not that one. It has a little vascular system here. I don't know if I have a picture of it, I think I don't. Yeah, here. It has a little vascular system that the here in the front, so that's not the same. The vascularity, the hormones, the hypothalamus secretes little hormones that then go directly to the anterior pituitary, and then the anterior pituitary secretes the adrenocorticotropic hormone and all the other ones, depending on what the hypothalamus told it. And the hypothalamus has in it hormones that are known as releasing hormones and inhibiting hormones. So you have one, which I didn't list because it just gets so big. You have one that's called adrenocorticotropic releasing hormone. And that's the hypothalamus talking to the pituitary. And then the pituitary I got to release the adrenocorticotropic hormone. And then that goes to the adrenal, and then the cortisol goes to the bloodstream. So it gets complex. But it's very important. And then it has one that's called adrenocorticotropic inhibiting hormone. And then that would shut off the release at the adenohypophysis of that adrenocorticotropic hormone. So what you have with that, you have a multi-level of control. Because once that hormone is in the system, it's going to go to the target, it's going to do its thing, it's going to run out its course. So we want to be very fine-tuned and very many places where we can switch and monitor what we're doing. And the highest level of control is the hypothalamus. And then the next, generally speaking, some of the stuff happens directly on the gland. But the hypothalamus is the big one, and then the hypophysis, the pituitary gland, is its executor, so to speak. Does that make sense? It's a little complex, but don't worry, we're just getting ready for the nervous system. The pineal gland is a pine cone shape. Okay, hold on, let's finish up these pituitary ones. So we have growth, prolactin, FSA, LH, we have STH, and then TSH. That's the metabolism. That's the other one. That's not the growth, that's metabolism. So the thyroid stimulating hormone goes from the pituitary gland to the thyroid gland, and then tells the thyroid gland to release thyroxine, and then that goes to the body cells and boosts up the metabolism. So this is one that if you have a hard time losing weight, for example, and it can be that the thyroid gland is not fully functional. So that's one place where it's like you can't do much. I mean, you can work on the gland, of course, but it's not about your willpower, so to speak, which is kind of a foolish thing anyway, I think, if you think about it. Or you have very wiry people, like you see their eyes are sunken in a little bit, they're like all jittery all the time. It can be because their TSH is high. You got people in the old days with a goiter down here. Remember? Have you seen pictures of that? Yeah, that's when this gland doesn't work quite right because we don't have what we need, iodine. Oh, iodinized salt. That's why we have it in the salt, because it helps it's a part of the thyroxine hormone, and that then turns on the metabolism. And so if we don't have enough of that iodine in the system, the body thinks it produces thyroxine, non-functioning. The body says, we need more, it's not working. So it makes the gland bigger and bigger, and that's the goiter. We don't hardly see it anymore, especially in our culture, but in other parts of the world, we have more of that still. So that's why we have iodinized salt, if you just were wondering why. I know, it's kind of good. And then we get to the pineal gland. So let's talk about the pineal gland here. It secretes melatonin. What does that hormone regulate? day and night rhythm. If you look at water balance, that will be back to the hypo and the ADH. And then cellular metabolism, that's just the thyroxine, would that be thyroid gland? And then the short-term stress response, we'll talk about that as the adrenaline. You remember, you have that yourself sometimes, I'm sure. Otherwise, you have to tell me what your secret is. There it is. It's associated with the third eye. If you do meditation type stuff, chakra type stuff, so they're kind of associated with that. That's why it's also in the hieroglyphics. That's what they think they meant by that. It's a very interesting hormone. It's an effective antioxidant as well. But I think for us mainly it's the day-night cycle is important. So you can take, it's to do with melatonin. You can take melatonin as a supplement, you can't go to sleep. But that's when we have to be careful, because if you take it and take it and take it, the body says, oh, look at that, we got melatonin, we don't need to make it. And then the gland stops making it as efficiently. So they say take a break if you take that. But that's also the thing, if you fall asleep, like if you know I watch a great movie, it's for me, it's 7:30, winter time, I'm getting sleepy. But the movie's so damn good, so I want to keep watching it. And so by 10 o'clock, I'm right awake. And then it's hard to go back down till 11:30. And so the problem is, I should lay down at 7:30 when I get sleepy. Because the melatonin is high, the natural melatonin is high, and I don't mess with the system. It gives you, I just listened to a podcast about better sleep because I have a heck of a time of sleep. And of course they say don't drink alcohol. It's like, really? Damn. But they also talk about, you know, when you start falling asleep, you go with the flow and go to sleep. And don't take the iPad into the bed or the phone. They talk about if you, what did he say? I have to review it again, but something like if you read in a blue light in the bed, and I'm not sure if it's just the blue light or also the dim, because I take the blue out on my phone at night every time. Your melatonin goes down 50% compared to reading a report like this paper. And so that makes a big difference. And so we gotta, you know, I'm not sure if it was the reading or maybe that was the wine. I have to read that thing again. But there's like some of these things we can do, like going out having sun helps us get more sleepy hormones coming up later on so we get back to bed. If we don't go out in the sun, the body doesn't have that reaction. So anyway, I guess we are animals, right? We just gotta kind of like have this brain go with the flow sometimes. All right, so one difficult losing weight is because on a functioning a gland. Oh, look at that! I already talked about it. Well, what does the hormone from that gland regulate? Energy production. Energy production. You think ATP, running around on molecules. So there we go. I think we talked mostly what we need to talk about that. Yep. I think that's good. And see right here, you got the Adam's apple, and then below, that's where it is. So the goiter is right there. We heard before of how important blood calcium levels are. Yes, many vital functions depend on it. Like the heart muscle contraction, for stuff like that. They're kind of important. We have two hormones that regulate that. So now we got a hormone, since we need that calcium level, we got a hormone that needs to dump calcium in if it's too low. And we got a hormone that have to bring it down if it's too high. We got a great plate. We got the bone. Bone has a lot of calcium in it, so we can all take the calcium from the bone and put it into the bloodstream. So which two hormones do we have that do that? One brings it up, one brings it down. That one? That one? Good. Calcitonin tones the blood calcium level down. That's how I remember it. Adrenocortico, yes, no? Parathyroid? Good, yes. So, those are those, and they're right here. So you take the thyroid gland out and you turn it around, and that's where you got those dots in the back, those parathyroid glands. So that brings the calcium level up. So first, when they worked on people with goiter, I think it probably was with goiters, but when they took the parts of the gland out, because it's like, why is there so much gland? They took some of these out, and these people, calcium was all messed up, and that didn't work out. So then they had to learn that, and so then they found that that's why they're in the back, so they're not easily to be found. They're very small. So we have those, and then we got some cells within the thyroid gland tissue. They call them parafollicular cells or C cells, and those secrete this calcitonin. And calcitonin turns the blood calcium level down. Oh, wait a minute. Oh, yeah. So, I thought I had it all wrong. So calcitonin turns that down. So the blood calcium level is too high. Calcitonin goes into the bone and deposits calcium in the bone. That's a good thing. You keep it in the body. We want that. It also gets rid of it in the intestine and pees it out. And so that's how we can get rid of it. If we need to bring it up because it's too low, we're going to go to the bone, we're going to get more out of the gut, and we're going to don't pee it out and keep it in the body. So that's the three main parts that the calcitonin and the parathyroid hormone work on. So that's a pretty nice visual. Simple. Wherever you can find a picture in anatomy and physiology, first in the textbook, you read the picture stuff. You look at the pictures, read the stuff under the pictures, and then go to the bolded terms. Otherwise, it's too much text. That's what I think. The adrenals, the sitting on top of the kidneys, they consist of a shell, which is called the cortex. So when you have whenever an organ has not all the time, but very often, the organ has an inside and an outside shell. The shell on the outside, they call it the cortex. And the inside, they call the medulla. So those are good to know. The cortex consists of 3 layers or zones releasing a different hormone with unique functions. Choose all of the hormones that are secreted by the cortex. Oh. Which ones? And cortisol. Not insulin and not epinephrine. Epinephrine is secreted by the medulla. So the cortex has got all these names. We don't need to worry about all these names. Again, for knowledge, you worry on what's on the review. But the names are basically the different areas that the different hormones are secreted. Aldosterone is secreted in the top one. We're going to talk about that when we get to the kidneys more. That's a good one. Cortisol, we just have a little bit here. And then we also have androgens that are secreted. So we've got testosterone stuff secreted here in both the men and the women. So women have testosterone too, they just don't come from the testicles, so it's not as much. And the guys have more of it. Oops. I like this here. The effects. The medulla oblongata is closely connected to the sympathetic fight or flight portion of the nervous system. That's when the lion is in the corner and you have to run away or fight. So that's like the feeling you get on the freeway, some stupid ass cuts you off and you can't do anything about it, and you swerve out. And then the first swerving out, that's the nervous system, making sure you don't get in danger. That's fast. And that goes away. And then you get the jitters. And the jitters is the adrenaline. And that's a great place. You can see how long it takes for the system, for a hormone to get secreted in the bloodstream to go to the cells and have an effect. So it's a very nice. It's pretty fast, actually.
Is that considered the limbic system? Limbic?
No, that's more emotional.
Okay.
So there is connections.
Is that fight or flight also?
Well, we have the hypothalamus that connects it. And we have, in the limbic system, we have the amygdala, which is the, you know, when you freak out, you get, you know, you punch the boy because it's just they got too much and you're like losing it. That's limbic system.
Okay.
So that's where there is a connection with that. But that's more of a, I mean, that discussion, we're more going to go trying to figure out how the heck we're going to calm that damn thing down when it fires up, so we're not going to have a freak attack. That's more the neuroplastic discussion. But there is very closely related. We don't work long-term on the limbic system, we're going to do this. And so this is nice. This is the short-term stress response. So look what happens. Sorry, it's a little fuzzy. Glycogen gets broken down. That means you get more sugar in the blood. That's good. You want to be able to run. Blood pressure goes down. That's good. You want to perfuse those tissues that moment. You think what happens in a stress response, you're thinking of having to run away from death. Like, you know, that level. And then you get to these functions. That whatever helps with that process is most likely what's going on. So you get more metabolism, you go to higher breathing rate, and changing blood flow patterns. Yeah, of course, more blood flow to the muscles and less blood flow to everybody else. Well, the brain too, but not the digestive tract or the kidneys. That's stuff we can do when we're sitting around, not when we're running. So that's great. That's short term. We want that happening. Now, if we're always bitching and moaning and everything is horrible and bad, and we're super stressed, I mean, it's not all us. It's also, you know, if we're in a society that doesn't give a crap in many ways, which we can argue, then we get long-term stress, like long-term financial, all that kind of stuff, that thing. And that helps us, or that secretes cortisol and the other one into the mineralocorticoids and the glucocorticoids into the system long-term, and that has all these effects. Increases volume of blood pressure long-term. The kidney sodium ions and the water balance is messed up in the kidney a little bit. And then we have, getting the system is used to get the body more energy. It's not built up, it's built down, basically. And so we don't have that build-up phase as much. And the immune system is suppressed a little bit. And a lot of that is when we use too much cortisol. That's where we can look at that side effect, so to speak. But what's important with that then feeds right into the long-term pathologies that we face in our society so much, including diabetes, including high blood pressure and all that kind of stuff. And so that's an important connection to kind of understand. And if we can consciously, not that we're always going to be good at it, but if we consciously understand a little bit of that, we can slowly change a little bit. And in the nervous system, I'm looking for some exercises to decrease that response that we can do, and also increase neuroplasticity, because that's what we want to nurture the brain with, to not be in this, we don't need to be like that all the time. Hopefully not. All right, does that make some sense? It's a little bit complicated, but I'm trying to explain it. So the medulla is the fight or flight. That's which one here? Epinephrine, adrenaline. Epinephrine, adrenaline, same thing for us. The pancreas is interesting too. It releases lots of digestive enzymes into the first part of the small intestine. So the pancreas has a couple of functions. So the one function, it's actually an exocrine gland. Digestive enzyme is an exocrine function if you're really technical about it, because the gut tube is the outside of the world. It's not inside. If you have the gut tube burst, like your appendix burst, then you move that stuff to the inside, and that's really bad, because then the inside gets inflamed, and that's an enclosed space, and we don't want that to be inflamed. So the pancreas has this exocrine gland function, and you associate that with digestive enzymes. Besides that, it also controls blood glucose level. It secretes a hormone that's called insulin that attaches to the most body cells and let the glucose enter into the cells from the bloodstream. So that's great, except when you eat, donut and coffee for breakfast, your glucose goes up really high, fast, all that processed stuff, and then you get all that glucose coming into the system, and all the cells open, and that glucose level drops really fast down, and you get the sugar blues and the sleepy blues. Because the brain doesn't pick up all that glucose as much as the other cells, and then you got a bloodstream with no glucose in it, what are you going to do? You've got to eat more. So that's why the donut, 2 hours, the next donut. The good old protein shake, I don't know, I do protein. It's something that goes slower. You can last for 4 hours because your energy stays up. So when we have the insulin take all the blood glucose out, we don't replenish more glucose in. We need the body to replenish it. Which hormone will do that? Which hormone can raise the blood glucose? No? Glucagon. Right here, glucagon. Yeah, the adrenals are cool, man. There you go. That's another one. That's one that, like the calcium, we have one that makes it worse, one that makes it better. I mean, one that brings it down, one that brings it up. That's pretty straightforward, I think. That one. That's a nice picture of the pancreas, just in case you need to study the anatomy. That's right. Also associated with the gallbladder and the bile as well. It goes travel through the pancreas. Okay, let's look at the next one. Oh, and then we got the sex hormones. Who secretes the sex hormones? The gonads. There we go. Good. And that's what they all do. I think that's enough what we need to know about them. It serves the development of the male and female sexual characteristic, roles, physical, emotional maturity, and the reproduction. And that works together with the other hormones that we've already had. So reproduction is a pretty big topic for the endocrine system. All right, good. So that's pretty good with that. And then, any questions on that one? Any other questions? Then let's see if I can pick up the understanding thing. So the understanding concept thing, what I'm actually trying to get out of is some interaction. So if somebody has a question and doesn't understand a concept, that's a good place to ask the people, the students, because sometimes I'm not that good at explaining things. And so I'm still working on how to fix that better, but just play with me a little bit along. And if you have any ideas for other classes, let me know. Maybe it's a different form that we should use or something. But, oh man, this is small. But here, I'm sorry, I can't make it bigger. The endocrine system works quite similar to the nervous system. Can you explain the differences listed between the two? We talked a bunch about it. The differences? Mm-hmm.
And the nervous system is fast.
So one is slow, one is fast. One, we can basically, if you want to study that, I think, for more detail than what we really need, I think that's definitely a good one to go. I like that consolidation. I think I could have used that enough for my chiros quiz. That would be good. So that's why I brought that up, because it will make you pay a little more attention to that part. And then hormones are either lipophilic or hydrophilic in their fundamental chemical structure. Remember, water loving, water fearing. Go back to the organic chemistry. Why are receptors for hydrophilic hormones located on the cell surface? Feeds back to that question. Remember, why is that the case? They can pass through the oil film on the cell membrane. So again, fundamental concept, hydrophobic, hydrophilic. If you have questions with that, make sure you talk to other students or talk to me about it, and I can go more into detail. A few of these fundamental things, if we understand them, the physiology is much easier with all the details put in. Which glands is in the cell of Turcica? List the hormones it secretes. We already did that. You did that?
Which one?
That's the hormones in the cell of Turcica. I mean the pituitary gland. So from that forward for the test, you do remember the hormones and the functions that are on the review. That gives you enough of what you need to know for the examination. And then the rest you can always look back. And then the adrenals, well, we talked about that. You can see how long-term stress can give us chronic conditions a little bit, right? Good. Excellent. Yeah, I've been really helped by when I get pissed off and I shouldn't react to something, but I feel like hitting something. I do that Barbara Tanner, Dr. Tanner brought us these flyers with the energy routine, but also there was one on there, I think, with the EFT, emotional freedom technique, with different points to press. And these up here, they bring you straight back out of that crap. So next time, you're really pissed off, just hit yourself a little bit and go here and then see if that helps a little bit. I know, because it doesn't help to be righteous, right? As we get older, it's like, why did we care about so much? It doesn't help to be righteous about everything. Okay, so let's move right along.